Hello and welcome to my video for Lab 1 for Physics 2212. So this lab observes the interactions between two charged pieces of tape and determines the excess charge on one piece of tape as caused by the experiment. And we're going to analyze those interactions and create both an experimental and computational model that analyzes those interactions on a deeper level. The major sections of this lab is an experiment section, coding, comparison, error analysis, a conclusion, and then an expansion on the what if / what does it mean questions. So some necessary things we're going to need to know for the experiment. An electric field will emanate from a point charge, which both pieces of tape for the sake of this experiment are being treated as point charges and are omnipresent as they permeate space. It is what cause electric forces to act between two objects, and then because we're assuming that the system is isolated, we can conclude that the electric force generated by the electric field is going to be equal to the magnitude of the gravitational force, which on Earth is equal to mass times the gravitational constant in the negative y direction. So in this experiment, we used 17 centimeter pieces of clear tape, a ruler, a desk, and 2 books to hold up the tape. The system was the tape in this experiment, and the surroundings were my body, desks, books, and the air. Both tapes are originally a distance from each other, and neither is close enough to exert a force from the electric field. It is not strong enough. We are assuming that there is no drag force and that each piece of U-tape has the same charge, and then an overview of the results, the tape was confirmed to be negatively charged with more protons than electrons. So in this experiment, we created 2 U-tapes, and then we made one tape float by suspending it and bringing another charged tape into close proximity. The distance and mass were recorded for the tapes, and calculations were made to determine the excess charge. After that, we made a computational model to observe the experiment in ideal conditions. So the calculations for the experiment, we first took the density, or not the density, but the mass over length ratio for a piece of tape, and we found the mass in kilograms of the piece of tape, and then we found the gravitational force. Because we don't yet know the charges on the individual pieces of tape, we were then able to plug this into the electric force equation using the magnitudes, and we're able to conclude that the charge on one piece of tape was equal to roughly negative 1.248 times 10 to the negative 8 coulombs. And then in order to determine the ratio of electrons to atoms on the piece of tape, we first found the number of electrons right here. We found the number of atoms, and then we found the ratio of electrons to atoms, which is about 46. As for the computational model, we basically tried to simulate the same experiment, but in ideal conditions, with arrows created to demonstrate each of the forces. So we have both of the electric forces, as stated by Newton's third law, are equal and opposite in magnitude to each other, so they both point in opposite directions, as well as the gravitational force, which points in the negative y direction from our system, which is this piece of tape. So the comparison, the charge from the computational model and the charge in the experimentational model are actually quite similar. They're only off by a small fraction of a number, but that does mean that there was something wrong, or not inherently wrong, but different in our experiment versus in their computational model. And to discuss that a little bit further, our experiment ignores the drag force. There could have been some AC or something running which causes some wind to move against the pieces of tape, which could have accounted for some discrepancies. And then given the human body is a conductor, contact with the tapes could have led to a transfer of charge, which would have led to an additional skewing in the results. And additionally, a ruler only has so many significant figures that can be rounded to, so it is also possible that measuring instruments could have a level of impreciseness. But to conclude, the net charge on a 17 centimeter piece of U-tape was concluded to be roughly 1.25 times 10 to the negative 8 coulombs at a ratio of roughly 45 electrons to protons on the surface. And then what if the charges on protons and electrons were switched? Because the tapes in this experiment were determined to have an excess negative charge, indicating an excess of electrons. If the charges on protons and neutrons are switched, then the tape would repel positive charges and attract negative charges, because we would be saying that electrons have positive charge. And then why is it important to handle the charged tapes as little as possible? Human bodies consisting of largely water and other conductive materials are thought to be good conductors of charge. This means that should we come in contact with a charged surface, then the charge would transfer through us. Because we need the charges to stay on the tape so that we can measure them accurately, we should try to handle the tapes as little as possible. Alright, thank you guys so much for watching.